Okay, welcome to everyone. Today we're talking about the API, Aggregation API and the Ibexa DXP. Well, it looks like we have almost everyone here joining. I am Linda Martin, the Digital Marketing Manager at Ibexa. Today we have Adam Luce and Yanni Treviani from our engineering team. Just before we kick it off, I'd like to cover off on some housekeeping items. All the participants have been muted to avoid background noise. At the end of the webinar, we'll open up the stage for questions. So as we go through the presentation, please do write your questions in the Q&A box. Without any further ado, I'll pass it on to Adam.
Thank you, Linda. Hi, everyone. Okay, so what we are going to cover today, we'll briefly start with look on what it is, Aggregation API, and how to use it. Then we will switch to 4 practical use cases. I will tell you what are the assumptions of each use case and and I will show you how I've built those examples using the Aggregation API. We will cover some repository metrics use case, some product review, implementing some product review page, as well as the tag cloud built from the keywords field type, and last but not least, facets search. At the end of this webinar, we'll have short Q&A session. Let's start with the first topic. What is Aggregation API? Basically, the Aggregation API is the API which allows you to summarize your data. This is pretty wide term because by summarize you could understand many different things. It could be some simple statistic like minimum or maximum value of some value, as well as some more interesting things like finding the rectangle which is boundary for your points over the map. Aggregation API has been introduced in the latest stable version of the product, 3.2. It's very related to the search, so is part of the search API, kind of. So it's worth to know that it's supported only with the SOAR Elasticsearch backend. At this point, you might ask yourself that we already had something very similar to this, which was named the facets in the product, and what's go wrong with it? Basically, the Aggregation API is successor of the facets in the product. There was few issues with the facets, like there were some design issues, or the developer experience of how you use this API was not that good as we would like to have. We decided to deprecate it in the 3.2 version and replace it with Aggregation API, just to be able to fix those issues and open possibilities for the future. Okay. How to use the Aggregation API? As I mentioned, the Aggregation API is part of the search API. So basically, what we are doing is build your search query as usually. It could be content or location query. You attach one or more aggregation definition into the query. Then you could just execute it using the search service, and you got the results which you can process anyhow you like. By aggregation definition, I mean basically the class which implements the aggregation interface from the API. And its role is pretty similar to sort clauses or criterions. It's basically the abstraction layer for for abstraction layer for aggregation, which is search engine independent. Okay, let me show you this in practice. Here I prepared some sandbox comment, which will be our playground for this demo. Besides all the boilerplate code, what is important here is, of course, that to use the aggregation API, I need reference to the search service. Then, as I mentioned, we build the query as usually, and then attach some aggregation definition. Each aggregation definition that is attached to query needs to have the name. It could be something like content group by type or content group by language, something meaningful. If you see on this class, yeah, it's what I mentioned. It needs to, our aggregation definition needs to implement this interface. So it's pretty easy to find our aggregation over the product. Yeah, and to have the most simple example, it's just query and attach the aggregation. And when we run it, you will see the table, which in this case, I've used the content type aggregation, which groups the content items by type and return the number of the content items which are of this specific content type. Yeah, here we execute the query with aggregation, and then we are accessing the first aggregation result from it, iterate over its results, and basically print it as a table. In single query, you could have multiple aggregation attached, of course. So for instance, when I add to this query language term, as well as enabled results here, we'll execute the single query and get the results for both aggregations. Here are the results. There should be language here, but yeah, it's the effect. What is more important here? Aggregation results are accessible via aggregations property. It's collection. Basically the wrapper for array object, but gives you some handful methods like getting the first aggregation results from what you attach into the query, or get the specific result of the specific aggregation using its name that we pass as a first argument of each aggregation definition. If you basically, the aggregations respect the filters on a query. So meaning, in this case, I will just narrow down the results for this three specific content types. Yeah, as you see, we just narrow down the results here. Also, the second aggregation as well respected. But what is important that in terms of executing aggregation, basically the offset or limit of a query doesn't matter. We could like execute it like this by setting the offset to 10 and the limit to 0. I will get the results of the aggregations as a whole from the whole result set, no matter of the current pagination settings. Yeah, and basically the basic flow of using this API looks like this. You create your query, attach your aggregations. You could, of course, have at this point and different options like putting some additional filters, set the offset or limit of the query, execute it, and yeah, just then process. because the aggregation result is a collection, and those two methods which I already show, you can on this collection iterate, just using regular for each loop. That will gonna work. You could as well check if you have some specific aggregation results, because some aggregation definitions might not be supported by the backend search backend that you are using, especially if those are the custom aggregations. So you could as well check if you get any results, any aggregation, or you could check if you get results for specific aggregation, like this. Yeah. In terms of aggregation results, each type of aggregation have your own specific type. We'll cover this later on. Okay. The next important thing, which will help you later on find the right aggregation to do the job for your task, is how we classify them, at least those which are built into the product. You could classify or group the aggregation by its result, and we have in product stats aggregation, term aggregation, and range aggregation, or you could group them by subject. For instance, you could have the aggregation which works on the content info data or location or search content fields. Kind of special group which violates the search engine independent rule is are raw aggregations, but there is use case for them as well here. Raw aggregation basically works on the search index field, raw search index field. Yeah, and based on this classification, we follow the naming convention. Each aggregation name is built from its subject as a prefix, then which is followed by the result type, and then with the aggregation suffix. Those are examples like content type term aggregation, integer stat aggregation, integer range aggregation. On this example, you could see why we decided, for instance, add this result type part of the name. Right, you could have different type of aggregation working on the same subject. Okay, this is the first part. Now we will jump into the first use case. Okay, what we are going to build. We would like to answer the following question. For instance, what is the minimum, maximum, average depth or priority of locations in our content tree? We would like to know what is as well, get some stats about the content version of specific type. Or for instance, we would like to get the percent value of the translation completeness of for specific language, right? And in general, get some interesting insights about our content repository structure. To build this, to build this, we will jump into another command which I prepared for you. This is as well the Symfony command, which will present the results for us. What we are going to do here is build the two queries. First one will take the metrics from locations. And as we mentioned in this with our goals, we would like to have get some stats about the depth of location and its priority. For this kind of stuff, I'm using the raw stats aggregation, which works on the which requires from me to hard code the search index field name. It's acceptable when we like building the tools like this. Any kind of like ad hoc tools, very urgent scenarios, and so on. Are there not something that I would use in production code or business related? Uh, yeah, for this, I'm using the stats aggregation. Basically, the stats aggregation like gives you those very basic stats over this specific field. The result for it will be like minimum, maximum, average value for this field. So once again, we are building a query. We attach the filter. We don't care about the search hit in this case. So I'm setting the limit to 0 and I'm attached the aggregation. As well, I'm doing pretty the same for the content metrics. I'm building the content query here, give it or pass into it some filters. As well, I don't care about the search hits, so I don't need them, so I will disable it by setting the limit to the 0. And now I attach the stats aggregation, which in this case works on the content version field from the search index, as well on language code row field from index. Of course, I'm naming each of the aggregations just to be able to easily reach the results of specific aggregation. And rest of the code is basically the output of it. Each method creates the query and executes execute the create query and execute it. As argument, I pass some filters which are built from command options. In this case, we have like two additional filters, like subtree or content tree options. Yeah, I'm building the criteria from the user input for this command, pass it through as a part of the building and executing the query. And then I will like go over the results and display each of it. Yeah, in this case, I will display them as a kind of table. And how it looks in practice. As a result, we will get output similar to this. It of course might depend on your, it will depend on your repository content. In my case, I've got like the average depth of the location is 2. Minimum and the maximum value is 1 and 3. All my locations have 0 as a priority. And yeah, in terms of the content, the like minimum average version of my content is 1 something. I could say less than 2, right? Those metrics might be interesting in point of view of seeing how the content repository has been designed, right? If someone, for instance, overused the priorities or the tree is too deep, and which might cause some performance issue or is about to limit of the depth. Language stats might be interesting if you launching the new language version of your site and you would like to ensure that every content has its translation to this specific language. In my case, I've got just only 2. In this Ibexa DXP installation, I've got just only 2 languages. The English is covered by 100% of the content items and just 2.5% and there is just only 2.5% content translated to the Polish language. Yeah, basically that's it. The aggregation, the raw aggregation allows you to compute such thing. I will as well show you the filters. For instance, I forgot about this one. We could narrow down those results to just only specific subtree in my case. And yeah, when I skip all media, users, and so on, subtree, the results in case of the translation are a little bit better. We could as well check this for media content. Yeah, all my medias are just only in the English translation for it. That was the first use case. And I will back and we will jump to some more web related right now. What we are going to build in this use case. We are going to build a very simple product review page. We assume that we would like to display some basic product information. In our case, this will be just only the name, but in real use cases, you will probably have the photos, the product as well, some description, maybe price, other fields. We would like to display 10 recent reviews with short summary, which will contain the number of the reviews and the average rate from those reviews. We of course assume that we will have like two content types. First will be, of course, the product, and the second one will be the review. Review will be very simple. We will have the author name, some rate field, and optional comment. And those reviews will be placed under the product's mine location. What I partially mentioned previously, for like building this, we will use the stats aggregation, which computes those very basic statistic values like minimum, maximum, and average value, and the partial results of it, like sum of the values and the count number of the values. Most of us know the SQL language or did something related to the relational database. So if you would like to translate the stats aggregation into SQL statement, this looks pretty similar to this statement that I'm presenting here. Yeah, we just select the minimum, maximum, average, and so on value of the field from some table, which in our case will be the all documents indexed in the specific search engine index. Yeah, okay. I will show you this and how I actually built this. That's what I mentioned on our assumption slide. We have some very basic product content type. In our case, it's just only the name. And under its location, I've placed some random generated reviews, which basically contains the author field, some comment, and the rate, which is integer number, basically. If we look on this, it will looks similar to this one. Here we display the product name, and here is our list of the reviews. Each comment will have, each review will have the author name, the rate displayed as the stars and the comment. And here's our summary, which is computed by the aggregation API. Here is our average average rate from those reviews, all of them, not only the first 10 that we displayed here. We have the number of the reviews that has been submitted and some graphical representation of it. In terms of the code, it's pretty easy, I guess, for everyone. First of all, I've configured the content view for my product content type. This view will be responsible for rendering the basic product information, the name in our case, and the comments part or review parts will be rendered as a sub request in our case. In our product review controller, which will be responsible for executing the query and present the result. We have basically the reference to the search service and the query type. We'll go into the details later on. Of course, we will pass this as this class dependency for this service. And then we have the simply render method, which builds the query, passing into it the current location ID, which is supposed to be the product, right? We execute the result and pass it back to the reviews view. Products review query type, right, is basically response for whole logic, which is for logic regarding the building the query itself. It's very simple. We just define just only one option for this query, which is the product ID. And then we'll build the content query. We set the limit to 10 because we would like to display the content. We would like to display the reviews, first 10 of them, most recent. So that's why we sort this result by date of publishing. We would like to make sure that we will get those only reviews for this specific product. According to our assumption, the reviews are under its location. And yeah, ensure that we'll just take into the account the reviews content items. And here we attach the integer stats aggregation. First argument of it is the aggregation name that we will use later on to access the results. And the second and third argument is basically the content type identifier and the field identifier, field definition identifier. Based on this, we'll based on content type and field definition identifier, we'll compute the search index field name and execute the aggregation on it. We of course returning the query here. If we go into the reviews page, it's very simple tweak file. It just only first of all I'm checking if there is any reviews. If yes, then I'm iterating over it. I'm extracting the name and rate value, display some comments and the author name and so on. There is one simple macro in this tweak template, which basically is responsible for rendering the average rate as stars. Basically, we see here with some basic summary. And before on the top of it, we are display very short summary of it. Here is I'm checking if I get any results for this rating aggregation that we attach into our products review query type here. Right, then I get those results. And in this part, I'm as well that displayed the average rate as a star, and then there is a very simple summary. Once again, the average rate has a number, and the number of the reviews that we that that we use to compute this average rate. And in this simple way, you could use the aggregation API to implement such kind of use case, having some products, book, or video, or whatever reviews page with this short summary. Okay, that was the second use case that we will talk about today, and we now jump to the third one. The third use case will be the tag cloud. What we are going to build is basically the tag cloud, which will be based on the keyword field. We will, of course, assume that some basic stuff, that the keywords will be sorted. Like if the most occurrence of the given keyword is in the results, and then it should be rendered using the bigger font. And of course, this font size, of course, needs to be in some kind of range, in some constraints. In this scenario, I as well prepared some code snippet content type and use the keyword. I will use the keyword field to attach the attach the programming language name into this snippet. But to build this, we will need the term aggregation. Term aggregation is basically the aggregation which groups some document content objects locations by some specific field, and then it will return for each of these groups, unique groups, the number of the document or content items that belongs to this or have this value. Once more, when we translate it into the SQL statement, it will look like this. We will select the value and count this value from some documents grouped by the value, right? Let me show you this in practice. I'll close this because we don't need it anymore. What we would like to achieve is basically something like this. It's a tag cloud based on, as we assumed, on the keyword field from my code snippet, which has just only the title and attached some random keywords into it. We'll sort those keywords, and the most occurrence is of the specific keyword, then we will have the bigger font of it. This view is rendered by my custom controller. So once more, what I'm doing here is to build a content query. I don't care about the search hits, so I'm like setting this to 0, limit to 0. I'm attaching the content type identifier filter into it because we would like to generate the tag cloud just only from code snippet content objects. And I attach my aggregation. Once more, I'm using here the term aggregation. This one is based on easy keyword field type. The aggregation will be named just tags. It will be run or executed on the content snippet content type and keywords field type. In this case, I would like to just get the 100 results, not more of them. So I'm setting the limit on the number of the return terms. As well, I don't want to have the take into account the code snippet which just have the one tag or two, we will take just only those terms which have at least 3 occurrence over the result set. Yeah, we execute this query and render results using the show HTML tweak view, and we pass into it the aggregation results from it. Basically, this view is pretty simple. The most stuff is happening here. This snippet is responsible for doing all of those stuff that we assume. Basically, to do so, we need to know, to render this tag cloud, we need to know what is the maximum value from whole result set. We, of course, here sort the entries from the term, get the key value just to be able to simply access them later on from each term's aggregation result entry. And we compute the font size for it and just display. Key in our case will be the keyword, and the value will be the number of the code snippet which have assigned this keyword into it. In practice, the result in my case looks like this. But if we take a look on how those data looks on step as a query and as a result, that should make more sense. First, the dump of our query. What I mentioned here is our keyword term aggregation with all the settings that I've assigned into it, and that's how it looks like our results. We got the aggregation results collection, which contains just only one entry because we attached just only one aggregation. It's named, of course. In terms of the term aggregation, we will get the term aggregation result object, which will contain entry for each of the occurrence or for each unique value. The key will be in keyword example will be our keyword programming language name, and the count will represent how many of these unique values we have, right? How many code snippets target with C# we have in our content repository. What's more important here, that the key of the term aggregation result will heavily depend on its subject. In this case, it's just a raw string, but in terms of you said previously, content type term aggregation, you will get here the content type object. In terms of the section term aggregation, you will get the value object representing the section, and so on and so on. Yeah, very simple results, but interpreted in my opinion in fancy way, interesting way. Yeah. Now we will jump into the last use case for today's webinar. In this case, we are going to build the facets search or facet navigation. We'll basically allow the user to narrow down the search results by applying one of the more filters, which will be generated based on aggregations result. We would like to be able to filter the results based on the content type section and some, let's say, creation date. I've already shown you the content type term aggregation and section term aggregation. Those two will be used to meet our first two requirements. For the third one, creation date, we will use the range aggregation. Range aggregation is a very specific term aggregation, meaning in this case, you will specify some ranges, and as a result, you will get this specified range and the number of the document containing value within this range. Once again, if you would like to translate it into the SQL, this could be interpreted as series of SQL statements like this. Basically, select the count from some value and putting each of the ranges as in the where statement. Let's see this in practice. Okay. This is what we would try to look. Here is a very basic search page. On the right side, we have search results. We display then the total number of the results. We have some very basic pagination here. On the left side, we have our facets for those result type. For instance, if I look for Ibexa in my content repository, I will just get those two results and those two facets here. And I click on the folder, the results will be narrowed down just only for the items which are the type of the folder, right? Of course, I can clear the filters. This will clear filters which we apply by the facet navigation, but query will remain. How to build this? In my case, this whole page is rendered by custom controller. Once again, it accepts as a dependency reference to the search service and search query type. Responsibilities are pretty similar, like in case of the product review controller. Search service we need it for executing the query, of course, and the search query type will be responsible for a whole logic of building the queries, the query that we will later on execute. Yeah. Scenario is pretty the same. In this case, I'm just building a query, pass into it the query parameters from request. It's a very simplified way of it. I'm just passing the parameters from query, but in production code, please use, for instance, here the Symfony form component, or for instance. I'm execute this query and once again render the view. If we jump into our query type, in this time we have more option. Query will be the user query, which is type here in our input. You will see that this is our query parameter. We have some basic filters like content type, which will go from here. Section and the scenes parameter that we add later on, and some basic pagination parameters which are used to control where are we in our results set by offset and the limit, just by default 10. Once again, I'm building the query, and based on my options, I'm attaching into it the query, and I'm attach the filters and some pagination results, pagination options. I'm attach into the query the content type term aggregation that you already know. Just name it content types. This will be as well later on needed for accessing those results when we will render the facet navigation for it. Build filter method, which is which is invoked here is as well pretty similar. We based on query type parameters, we have built our filters. Yeah, and we just return it. If we go into the view for this action, it will look like this. Of course, I have this header section of it, which will render basically Ibexa logo and the search query form. Then I have the results rendering logic, which is here, just displaying basic information, content type name, it's indexed in the whole the results set, and then information about the content type and when it was created. It will be we will need it later on. I'm checking if, of course, I've got any aggregation result, because maybe my search engine does not support the aggregation API. It's not the case here, because we are using Elasticsearch under the hood. And the whole facet navigation rendering logic is moved into this facets HTML twig file. And what I'm doing here, besides the front-end stuff like rendering the facet navigation, facet name, I'm iterate over the result for this specific facet specific aggregation result, and I'm generating the URL, which is basically exactly the same as we have here, but we've attached the parameter of the content type that should be that we will filter on when we click on this link. And to do this, I'm use just simple merge function combined with the current request query. Of course, in such scenario, we have to reset the pagination to back to the first page. As you may notice, the term content type term aggregation is basically term aggregation. This result is iterable, so here I will get the content type object, account for it, and then I'm generating the URL. Okay, that was the first filter that we would like to support. Now let's add some. Let's add some another one. I've already prepared this. To do this, I'm just attaching the next aggregation into my search query. And once again, I'm rendering it. It's very similar way as in case of content type. This is as well the term aggregation. This will give us the following result. But in this case, I'm not logging, so I'm not able to see any sections, of course, because the aggregations results are permission aware, right? Now, when I'm the user which could have enough permissions to be able to load and see the sections, I see not only just the section, but way more results for it. And if we check it, right now I could, for instance, filter by the section. Yeah, it's the standard section what I've choose, and I could as well narrow down those results to specific content types. In my case, those are the reviews. Yeah. In case of our third filter, now I will use the date metadata aggregation, which basically requires from me specify, of course, the name of this aggregation, what we will be used for aggregate on this result. It's similar to date metadata criterion. You could choose the creation date, publishing date, and so on. Because it's range aggregation, I need to specify those ranges. So what I'm doing here is basically create for each range that I would like to have, specify the beginning of it and end of this range. In this case, we'll take the current date and subtract from it 1 day, 7 days, 14 days, 30 days, and so on, just to generate those ranges. On this point, we should be able to see this. What I'm doing, even if it's not applied, the filter is not applied yet, we already render it just by iterating over the range results, range aggregation results, which is pretty similar to terms aggregation, with only those difference that as a key you will get the range which was defined in aggregation definition. Yeah. From date to date and the number of the items which has been created in this. Of course, I need to take care of applying this filter. Oh, I forget about this one. Now it should work as expected. Yeah, and now I could filter those results, and the numbers will change and so on. And basically, that's it. This is one way how you could build the facet aggregation, a facet navigation, and enhance your search results page with those filters. And now we will go into Q&A session.
Yes. So I thank you, Adam, for the excellent session on details. I took the liberty of answering a few questions in line, but I want to review them so we'll make sure that everybody hears them. So from Johan and Diadi, we heard the questions, will this be available with a Solr backend, and what about legacy search engine?
Aggregation API is available in Solr backend as well as the Elasticsearch, but it's not available in the legacy search engine, and we are not planning into adding it. Yeah.
Okay, thank you. And then from Douglas Hammond, we have a question. Will there be a pager adapter that allows you to get the aggregation results?
Yes, this is one of the features that we plan for 3.2 version, which is incoming. Not only gets the aggregation results from the pager Fanta results or adapters, but as well other search results data like the maximum score from the search results. It was if the results was timeout or what was the time of executing the search query and so on. So there is already pull request open with this on Easy Platform kernel repository.
Thank you. Then from Ivan Ternovsky, are you going to add some repository stats in the admin UI in the future?
I'm not sure if I understand this question.
I think regarding the number of objects and so on in the admin backend, so you could see from the admin tab how many objects your repository has and so on.
Okay. We don't have any plans yet for such to having those metrics in admin UI yet, but it will be, in my opinion, very useful. So we will discuss this and think about this, but nothing planned in the nearest releases.
Then another one from Ivan. regarding it's a bit more technical, but if you need only minimum and don't need maximum, average, and so on, is it only possible to get the minimum value, or will performance be the same for loading minimum value only for all stats?
Basically, you will get whole statistic results at once, meaning minimum and maximum value, and it doesn't matter computing both of those or just single one of it. To get this value, you need to override the whole result set. So finding minimum and maximum, it doesn't matter actually. So you will get all of those at once.
Thank you. And then from Johan Monier, is it working with easy tags, NetGen tags?
I cannot answer this question, but I think it will require implementing the aggregation for easy tags. I guess that this is the name of the field type. One of the assumptions that we took when we designed the aggregation API is that the field type the developer who implements the field type knows the best what the aggregation could be possible on the data that he stores in search index. So the person who implements field type is responsible for providing the aggregation specific for this field type, which you might see when I'm using the integer stats aggregation or keyword terms aggregations. All of those are specific to this type. Besides that, you should probably be able to easily use the row aggregation, but there is this concept that you need to hard code the search index field name for it.
Good. And then one more short question. So what you showed how the PHP API works, but how does the GraphQL and REST API support the aggregation API?
All built-in aggregations are support, of course, as well via REST. Very similar to what is in the PHP API. You basically attach the aggregations definition into view input, and you will get very similar to PHP API results. Also very specific for each of the type of the aggregation. Regarding the GraphQL support, we do not support yet the GraphQL and Aggregation API. I'm working on this, but it's still in progress.
Okay, if you can return to the slide. Sure. So one question which we would like to ask you is a bit of feedback from this developer session. So if you can please go to the address ibexa.co/AGAPI, AGAPI. There's a short questionnaire where we have a few basic questions for you regarding this webinar. What kind of topics would you like to have, and how did you feel about this session, and so on. In addition, what we will do is we will have a recap of this session in a blog post where we will post all the materials, details to how you can see the code and so on, and including the slides and everything, and the video recording as well. So this is something we plan to have for you during next week as an early Christmas present. So I hope this one will be useful for you as well. And since we are already short on time, I would like to thank you, Adam, for his excellent presentation. And I hope this session was useful for all the attendees. I hope you will be able to use the aggregation API in your implementation projects in the very near future, because I have used it and it's very intuitive and nice. Thank you, and have a good evening.
Thank you. Bye.
Bye.